Okay, so we're going to start with elimination just because I show you substitution and elimination. In this case, we didn't do graphing, but those two, so that way you can pick which one you prefer. Both of them would work, okay? So we have our sample problem already. Now, the first thing, right, so our steps. This whiteboard. So our steps. The first one.
Brianna's calling me, so I'll like.
Okay. So in our steps, the first step to do is to pick the variable to eliminate. So which one do you want to go with? You have X, Y.
I remember us doing this. Like we can do like Y.
Okay, so when I'm picking the variable, Y we can do, but I like to pick ones that have at least one negative, that have at least an opposite, right? Because if I pick Y, then I have to multiply by a -1. And I've noticed that when we multiply by -1s, things can get a little confusing. Unless you're okay with doing the -1, then we can do Y if you want.
So then Z, then the
yeah. So
okay.
Z is another one that we could do because it has that plus or minus. So Y is not wrong, right? You can pick any, you could even pick X if you wanted to. My advice is to pick the ones that's going to be the easiest to deal with, right? And if there's a negative, I know that I don't even have to multiply by a negative and risk getting confused. So we can do Z or we can do Y. What's your final answer?
Z.
Z, okay. So in this case, I'm gonna put this in this color. We are picking Z. So we have, now the next thing I need to do is I need to pick two equations. So I have, here's equation 1, 2, and 3. Now you can pick any two, and we're gonna pick one, we're gonna deal with the third one after. So which is the first two you wanna work with?
The first two, like
the first two. Yeah, okay, that one's good, right? Because it's a plus Z and a minus Z. So I don't actually even have to multiply anything. So I pick two equations and solve, or actually it should be and eliminate Z, right? Because Z is the one that we picked. So we have X plus 2Y plus Z equals 8. And then I have 2X plus Y minus Z equals 4. So now I don't have to do any multiplications or anything like that. I can just add, right? So what is, there's a 1 up here. So 1 plus 2 is?
3.
So 3x. 2 plus 1, again, it's also 3, but now it's y. My z's are gone. And what is 8 plus 4?
12. Wait. Oh, that's a Z. I thought that looked like an 8. Sorry.
Oh, this one's an 8. This one's the Z. So it's going to be 12. So now I want to hold off using this equation. I'm not done. because now step 3 is to solve using the third equation. Hi, Diana. Thanks for joining us. Just to let you know, because we already started, but the recording will go up on YouTube and you can watch what you missed for the time being, okay? So now I need to work with the third equation. I don't have a lot of room over here. So the third equation has to be that x plus y plus 3z equals 7. Now, which of my other two equations do I want to use to cancel out that z this time? Equation 1 or equation 2?
Equation 2.
Yeah, right. Equation 2 still has that negative z, meaning I don't have to multiply anything by a negative. But what will I have to multiply by? Because I need my z's to match. So if one is a 3z and the other is just z, what do I need to multiply so that they match up?
Like multiply all the variables by?
Multiply the entire equation. So which equation should I look to multiply? The first or the second one?
The second one? I'm not sure.
The second one, right? I have on the top one, I have a 3z, right? The second one, I have a negative z, or really a negative 1. So it's going to be easier for me to get that 1 to 3 than it'll be to get that 3 to 1, right? I would have to divide everything by 3 and then I'd have fractions and I don't want to deal with that. But I can multiply by 1 or 1 by 3 to get to that 3z. So what I'm going to do is I multiply everything by 3. Because what I do to one variable, I have to do to everything else. Okay. So this first one stays as is. I'm going to write in a different color. So x plus y plus 3z equals 7. Now 2 times 3?
6.
6x. 1 times 3 is just 3y. And now I have a minus 3z equals. What is 4 times 3?
12.
12. So now once again, just like I did over here, I'm going to now combine my terms. So this is a 1. So 1 plus 6?
7.
So 7x. 3 plus 1, that's 4. My z's cancel. And now what's 7 plus 12?
19.
19. Exactly. So now I have two equations. I need to add an extra page. Okay. So let me rewrite my two new equations over here. So it's 3x plus 3y equals 12. And 7x plus 4y equals 19. So now I'm going to continue my steps. And my next step is going to be, well, I kind of already did it, which, what step were we last on? 3? So this is 4, yeah. Step 4 is write the two new equations as a system. So now this should look more like that practice I gave you guys on Halloween. I don't think you were there, Diana, when I gave out the worksheet. But this is something we should have done back in Algebra 1. So I know our memory on Algebra 1 may be a little bit spotty, but this is much more manageable than having 3 variables. So then step 4 or step 5, I'm running out of colors here. No, I don't want you to do yellow. Step 5, can you guys see? Yeah, that looks fine. Is solve for the variables. So now once again, I'm going to repeat the same steps that I did over here. I'm going to pick a variable to eliminate. Now I don't have to pick 2 equations, I only have 2 equations. So I'm just going to look to see what I'm going to eliminate. Now in this case, both of them are positive, so I'm going to have to multiply one equation by a negative number, but we can figure that out when we decide which variable do we want to get rid of, X or Y. There's no wrong answer. You guys just tell me which one.
X.
X, okay. So now I need to figure out what number 3 and 7 can have in common so that I can cancel them out. Now, unfortunately, 3 times 7, they don't really have anything until you actually multiply 3 times 7 and 7 times 3, right? Like if I list the factors of 3, 6, 9, 12, 15, 18, 21, 24, 7 is 7, 14, 21. 21 is the first thing that they have in common, right? So I have to get 21. Now, that means that I multiply this top equation by which number?
So you have to get 21. Like what do you mean?
So I have to, right, because I need them to cancel. So if I'm going to cancel them, they have to be the exact same number, right? 5 minus 5 is 0. So since I have 3 and I have a 7, I need to figure out what's the first number that they both have in common. So I can do that by listing my factors. I tried to fix my 6, it came out horrible. So I do that by listing my factors and seeing the first number that they both have in common, right? So in the case of 3 and 7, the first one that they both share is 21. Okay, so that means that I need to multiply both of these equations so that that X, one becomes positive 21 and the other is going to be negative 21. So that way I can get 0. So what do I need to multiply this first equation by to get 21 for that 3x?
7?
7, right? Now, do I want to multiply it by a negative 7 or a positive 7? Again, there's no right or wrong answer. I'm just asking your prep if you guys want to do it that way.
Negative 7?
Okay, so we're going to do the top one as a negative. So everything gets multiplied by negative 7. So now my bottom equation, everything gets multiplied by what number?
does it have to like does it have to equal the same as the equation on top of it, or
Exactly. So 7 needs to become 21. So what do I need to multiply to get to 21?
3?
3. So everything in the second equation gets multiplied by 3. So now I'm going to change the color. So it's going to become a negative 21x plus, or no, minus 21y equals, and what's 7 times 12?
84.
84. All of these now become a negative because all of them in the original were positive. Multiplying by a negative number, positive and a negative is always going to be a negative. So now in my bottom equation, 7 times 3 is a positive 21x. 4 times 3, what's that?
12.
12. And then 19 times 3. Okay, so that one's a bit of a one I can do here on the side. 9 times 3 is 27. 3, so 57. So far, so good. You see what I had to do? Now I can eliminate that x. So now this x is gone. Now I need to do 20, what is, okay. 21 negative plus 12. Remember, that's the same thing as saying 21 minus 12. Which is my larger number, 21 or 12?
12.
What?
Wait, isn't it negative 21?
Yes, negative 21.
So large number?
Yes.
12, right? No.
No. Like just without looking at the negatives. 21 or 12, which is bigger?
Oh, 21. I thought you were including the signs as well.
No, I'm just putting already that my answer is going to be a negative answer. So then now what's 21 minus 12?
Nine.
9. So 9y equals, same thing. This negative 84 is bigger, so my final answer is going to be a negative answer. Now, 84 minus 57. What is that?
$27.
Is it? I don't know. Let me see. This becomes 7, 14. Yep, 27. Now what's my last step to solve for y? So what is the last thing I need to do?
Don't you need to like divide the 9?
Exactly. Now I'm going to divide by a negative 9. So then y equals a negative and a negative become a
Positive.
positive. So now what's 27 divided by 9?
3.
So now my y value is equal to plus 3. Now my step is really my last step. Step number 6. Yellow is not a good color. So step number 6 is now we're going to solve for the other variables. How I'm going to do that is I'm just going to go ahead and start plugging in my y value, right? So in this first set of equation, this 3x plus 3y equals 12 and 7x plus 4y equals 19. Which equation do I want to use? Again, there's no right or wrong answer. It's just whichever you prefer. The first one or the second one? What do you think, Diana? Which one?
Y?
Okay, wait, which one do you want to use? The first one or the second one?
Oh, the first one.
Okay, so we're going to use the first one. I think I need a new page. So it was 3x plus 3y equals 12. Now I know y is equal to 3, so I can replace y. Everywhere I see a y, it's now going to become a 3. So 3x plus 3 times 3 equals 12. So what is 3 times 3?
9.
9. 9 equals 12. Now what do I do next?
Don't you subtract the 9?
That's exactly what I do. I subtract 9 to both sides. So 3x equals, what is 12 minus 9?
3.
3. Now when I divide by 3, x equals what?
1.
Just 1. So now y is equal to 3 and x is equal to 1. So I have to go all the way back to the beginning at my original 3 equations. Veronica, pick the equation I want to use so I can figure out what z is. Which one?
Wait, to figure out z?
Yeah, we need to find out what z is. So I pick one of these 3 equations because now I know what x is. I know what y is. I just need to solve for that z.
And there's no wrong answer?
No, there's no wrong answer. You just pick one of those 3 equations.
Can you hear me?
Yeah?
The second one.
Second one? Okay. So that is 2x plus y minus z. 2x plus y minus z equals, what was it? 4. So now, again, just like I did in this problem, I replaced y with 3. I'm now replacing my x and my y with 3 and 1. So 2 times 1 plus 3 minus z equals 4. So 2 times 1, that's easy. It's just 2 plus 3 minus z equals 4. What is 2 plus 3?
5.
5. So 5 minus z equals 4. Now, just like I did over here, I'm going to subtract 5 to both sides, which gives me a negative z equals, what is 5 minus 4?
1.
1. Now, which of my two numbers is bigger, 4 or 5?
5.
5. So I'm going to keep the sign of my larger number, which is a negative. Okay? But now I can't have a negative variable. So that negative z, I have to change it to a positive z. So what do I have to do then?
Oh, I don't know. The multiply?
Multiply it by what?
Positive number.
So remember that a negative and a positive will give me a negative, but a negative and a what give me a positive?
Oh, a negative number.
A negative. So I just want to multiply by -1, right? I don't want to change anything. I just want this negative z to be a positive z. So a negative and a negative is a positive z. And so a -1 times -1 will give me what?
Positive 1.
Positive 1. So z is equal to 1. So my final answer, how I would write it, is x is first, 1, y is second, so 3, and z is third. So x, comma y, comma z. So that is 1, comma 3, comma 1. That's the correct answer. Does it make a little bit more sense?
Yeah.
It takes time, okay? These problems are not ones that you're going to be able to solve in 5 minutes. It might take us a little longer, but you take your time, you do the steps, and you'll get the answer. There's no race. It's not a race. Do we want to do another one of these problems?
Was this was elimination, right?
Yeah, this was elimination. You want to do substitution?
I mean, yeah, sure.
Okay, we can do both. Let me get a new page. Let me get a new problem. So, this whiteboard and this Zoom is not the easiest thing to use. Okay, so let's see our new problem. It's going to be 2x minus y minus 3z equals 1. Are you sure Brianna said she was going to be here in 2 minutes?
I don't know. Maybe she'll show up.
That's not like the longest 2 minutes ever. It was -4. And then the last equation, so negative -3x plus 2y plus 5z equals -3. Okay, so in elimination, the first step is I need to figure out which variable I want to use so that it's the variable equals, okay? So in this case, oh, Brianna messaged me. She's not able to join. We'll have to help her out later. So the first thing is I want to pick the variable and solve for it. Now in this case, I want to see if it's possible to get a variable that has no number next to it. So this example, it's a little bit challenging, but there is one. So which variable do I want to use?
The y in the first equation?
I want to use the y in the first equation. So pick a variable and solve for it. Right? Because that y in this first equation is by itself. It has a negative, but I can deal with negative. I just don't want to have to have a number in the front because then that means I have to divide everything by a specific number. And looking at these numbers, I'm not going to get anything nice. They're going to be fractions, and I don't want that. Okay, so now I need to get it so that my equation says y equals. That's my goal. To get that. Can you guys hear me? Because my one
Yeah, we can hear you, Miss Cordova.
kicked me out of the Zoom. So, so we're just trying to get it back.
I turned off my camera because like last time this happened, it kept on recording and it showed my face and I freaked out. So I'll put it back on once you come back.
But if you guys can still hear me, what is it that I need to move in this 2x minus y minus 3z?
Like move for what?
Okay, there. Now I can hear you. I was having issues. I couldn't hear you guys. So what were you saying, Veronica?
Like move for what? Like
So
sorry.
my y is where I want it to be, right? Because I want y equals. So y gets to stay, but what else is on the same side as my y that shouldn't be there?
That should be there or shouldn't be there?
What?
That like what else is on the same side of the y that should be there or shouldn't be there?
Shouldn't be there. Because I want y by itself.
Oh, the x and the z.
Exactly. So I need to move both of these over. I don't know. What is this? I need to move both of these. So that way I can have it as my y equals. So what's the opposite of positive 2x?
Negative 2x.
Negative 2x. So I'm subtracting 2x to both sides to get rid of that one. So now I have a negative y minus 3z equals a negative 2x plus 1. Now, just like you said, Veronica, I have to also move this z. So what's the opposite of the negative 3z?
Positive 3z.
Positive. So I add it to both sides. So now that one's gone. So that gives me the negative y equals negative 2x plus 3z plus 1. Now, I only have one thing here that doesn't belong, right? Remember, I need it to be a positive y. My y here now is what? Positive or negative?
Negative.
Negative, meaning I have to multiply everything by what?
Positive? No. No, negative.
Negative 1. If I multiply everything by negative 1, I will now have that y equals, now a negative and a negative, positive 2x minus 3z minus 1. Do we see that? Okay, so now I can go ahead and I can use this equation and replace it in my other two. Okay, so I have to do it with both of them. So let me go ahead and write y equals, what was it? 2x minus 3z minus 3z minus 1, right? So now it doesn't matter which one I do first because I need to replace both of them. So which one do I want to do first? 1 or 2? No wrong answer.
2.
Okay, hang on. Okay, now we should be better, right? Okay, now I have it back. So my main screen is back now, which is a good thing. Okay, so which do I want first, the second or the third one?
The second?
Second one, sure. It doesn't matter, we have to do both anyway. So the second one is, hold on, 4x. I'm gonna write it in the black. So 4x plus 3y plus 2z equals negative 4. So now, just like in the last one when I found that y equals 3 and I had to replace it, I'm doing the same thing here, only I don't have an actual number. I have a whole equation. So step 2 is to substitute the variable in both equations. So here I have my 4x plus 3. Now here's my y, so it's now going to become a 2x minus 3z minus 1 plus 2z minus 4. Now I need to work with my Pemdas. My Pemdas involves doing the multiplication of all three of these. So I'm going to have my 4x. Now I'm multiplying these 3. So 3 times 2 is 6. We have to keep that x. And then I have a positive and a negative, meaning my final answer is going to be negative. And 3 times 3 is 9. Again, I have to keep that z. And then another negative and a positive, which again is a negative. 3 times 1 is just 3. Plus 2z equals negative 4. So now my next step is to combine my like terms. So I have x over here. an x over here. I have a z right there. And I have a z over here. And then this 3 needs to combine with that 4. So I'm already just going to add 3 so that I don't have to worry about that. 4 plus 6 is 10x. We're running out of time, so I'm going to kind of go through the calculations a little bit quickly, but it's just addition, and it's just combining like terms. Now, a -9 and a +2, 9 is my bigger number, so my final answer is going to stay negative. And then that's just 9 minus 2, which is 7z, equals, again, 4 and 3, 4 is bigger, so I keep that negative. And then 4 minus 3 is just 1. So that's done for the first equation. Now I need to go ahead and do it with the second one. So the second one, again, I have y equals, what, 2x minus 3z minus 1. And now my second equation, or really equation number 3 in my original list, was -3x plus 2y plus 5z equals -3. And again, I do the exact same thing. I just go ahead and I plug in that y. That's not the same blue I was using. I'm just going to go in and replace that y with, I'm looking at the wrong equations, 2x minus 3z minus 1 plus 5z equals -3. Again, I distribute to get rid of my parentheses. So that's -3x plus my 2 times 2 is a 4. 2 positive and a negative give me a negative, and then 6 times 3 is just 6, or 2 times 3 is 6, z. And again, negative and a -2 plus 5z. Everything else stays exactly the same. Now, once again, I'm combining my like terms. So there's an x, there's an x, there's a z, there's the other z. And again, I'm just going to start off by adding that 2 to both sides just to get rid of it. Okay, so now this is a -3 plus 4. So 4 is my bigger and it's a positive, meaning my final answer is going to be a positive number as well. So 4 minus 3 is just x. Now I have almost the same thing over here with z. I have a negative as 6 and a 5 plus. So -6 is my larger number, so it stays as a negative. And then 6 minus 5 is also just 1. So it stays as z. And then, wow, again, everything is only 1 apart. So the 3 is the larger, it stays negative. And then 3 minus 2 is just 1. So that actually looks really nice. That's really easy for us because our next step, just like it was before, is to now write a new system, which includes this. Let me go to the third one. 10x minus 7z equals -1. So 10x minus 7z equals -1. And then x minus z equals -1. So once again, my next step, which number is that? Step number 3 is to solve the new system. So I can either do this part as elimination or substitution. Which would we rather do, elimination or substitution?
Elimination.
Elimination, okay. So then I have my 10x minus 7z equals -1, and x minus z equals -1. So this one is much easier than the last one we did because the x and the z both have 1, meaning I don't need to multiply both equations. I just need to multiply this one. So now, which variable do we want to eliminate? X or z? Again, there's no wrong answer. Just tell me which one you want to do first.
X.
X. So then what do I need to multiply this whole bottom equation by?
Oh, by 10? No, I don't know.
By 10, yeah. But now I need it to be negative 10 because this is a positive and a positive. So to cancel it, it has to be a negative. So a negative 10, negative 10, and a negative 10, which now gives me 10x minus 7z equals negative 1. Now negative 10x plus 10z equals positive 10. So now once again, I just go ahead and do the math. 10 minus 10 is 0. 10 minus 7, so again, 10 is positive, so this number is going to stay positive. And 10 minus 7 is just 3. And now what's 10 minus 1?
9.
9. So what's my last step?
Divide the 3.
Divide by 3. So that gives me z equals 9 divided by 3 is just 3. And then my last and final step is the easiest one. Solve for the others. So because I have z, I'm going to use this second equation because I don't have to do any kind of division. All I have to do is say x minus 3 equals negative 1. I'm going to add 3 to both sides. So then x is equal to, that's just 3 minus 1, which is 2. So right now I have 2 of my numbers and I just need that third one. So I'm going to go back to my original y equals, what is it? 2x minus 3z minus 1. I know that x equals 2 and z equals 3. So y is going to equal 2 times 2 minus 3 times 3 minus 1. So 2 times 2 is 4. 3 times 3 is 9. And then minus 1. So if I subtract all of that, let me do the first two. 4 minus 9 is what?
5.
5. Negative. So remember that negative is there. 9 is the bigger number between 9 and 4. So then negative 5 minus 1 is the same as saying y or 5 plus 1, but I keep the negative, so what is it?
Negative 6.
Negative 6. So my final answer, 2, comma, negative 6, comma, 3. Does that make a little bit more sense? Yes, maybe.
Yes.
Okay, so I'm going to put the extra credit problem now for those who missed this session. And it's going to be to solve 4x plus y minus 2z equals negative 6, 2x minus 3y plus 3z equals 9, and x minus 2y equals 0. So this is the one to solve for the extra credit for the people who weren't able to attend, and they will have until Monday by 8 p.m. to submit that to me. So thank you, Veronica and Diana, for joining me today, and enjoy the rest of your weekend, and I will see you on Monday.
Thank you, Ms. Perdomo. Bye.
You're welcome. Bye.